Hello everyone. Today we will be seeing about how to write the Verilog code and verify it for the half header. So I will be showing you how to write the Verilog code for a half header in two different ways. One is the data flow modeling of Verilog and another is the structural flow modeling. So let's first write using the data flow modeling. So here we have to declare the module and the module name, inputs a comma b, output sum comma cout semicolon. So we have to declare the keyword input where we have to give the inputs variables. Similarly for the output, cout. Now as we know in the half header, the sum will be XOR of the a and b, and the cout will be and logical AND of a and b. So in the data flow modeling, we will directly assign, like we use a statement assign sum equal to a XOR b. So this is the data flow modeling where we assign the output to the input using operation. Similarly, assign cout equal to a and b, and we have to end the module. So this is the data flow code for a half header. So now let's see how we can write the test bench to verify it. So first module pb. So we have to declare the inputs as register reg of a comma b and outputs as wire of sum comma cout. After declaring this, we have to instantiate it. So half header, we have to give the same name as of here, and this is user friendly name. You can give anything. So user friendly name. So in that we have to declare as it is, how we have declared in the Verilog code, a comma b comma sum comma cout. Close. After that we have to write the initial begin. In that, if this is the completely optional statement, but I suggest that you should write this statement as it is help to visualize it in the text output in the textual manner. So monitor $monitor. Here you can give the time also if you want. So a equal to percentage b comma b equal to percentage b comma sum equal to percentage b comma cout equal to percentage b. Here we have to give as, just a second. So a comma b comma sum comma cout. So after that we have to give dump file. We have to give the name. I will give it as dump.vcd. It is a file extension .vcd, and dump vars integer 0 comma, and you have to give the name, this name, test bench module name. So after that you have to give the values, like first I will give a equal to 0 and b equal to 0. After a timestamp of 10, I will again change the value a equal to 0 and b equal to 1. Similarly, after another timestamp, I will change it a equal to 1, b equal to 0, and after another 10 timestamp, I am going to give a equal to 1, b equal to 1, and we have to end the initial begin, and we have to end the module. ODUL. So to click this, and in tools and simulators, go and select Icarus Verilog 12. So let's see how the data flow modeling, whether it is correct or wrong. So let's run it. So as you can see, there is something syntax error at testbench.sv on the 8th line. So what is it? Dumpwares. Okay. So see here, I have forgot to add a semicolon. So it throwed an error. So let's rerun once again. Okay. Oh, spelling mistake. One second. Dump file. Rerun. So as you can see, this is the waveform. You can go through the waveform, but this is might be quite difficult to like analyze. But after we have write the dollar monitor statement, here we can see the visually. Here we can like give some gap so that it may run properly. So we can minimize it. As you can see, here are the timestamp, and as you can see, a equal to 0, b equal to 0, sum is 0, cout is 0. If any one of this is 1 and another is 0, the sum will be 1, cout will be 0. And if both are 1, sum will be 0 and cout will be 1. So this is how the data flow modeling works. And you can verify this output with the truth table of the half adder. Now we will be seeing like how the structural modeling will work in Verilog. So the code will remain same for the test bench, but the change will be here. Like instead of assign, we will use direct the name of the gate like XOR. First we will give output sum comma a comma b, and similarly for the cout output a comma b. So let's rerun once again. So as you can see, the output remains the same. So the difference in between the structural and the what we say data flow modeling is that in structural modeling we use the predefined already logic defined in the Verilog, and in the data flow modeling we use the assign statement. So that's it, and in the next video we will be seeing about how to write the Verilog code for full adder with a test bench. That's it.